So this is Raspberry Pi. Essentially, this is a $35 Unix box. It runs Linux in a variety of, it runs a Linux kernel with a variety of different distributions on top of that. You've got GPIO, so you can make things move sort of Arduino style, make lights flash, make motors move, react to things. You've got USB, so you can plug in webcams, Wi-Fi adapters, USB Christmas trees, those kind of things. It's got networking, so you can easily do all sorts of cool networking-based projects. In Python, you import the web libraries. You can use JSON to make an LED turn on based on someone tweeting a word in less than a couple hundred lines. Right? It's pretty cool. And we've got HDMI out, which allows you to get it on TVs like this. This is running on a Raspberry Pi. Supports 1080p and 720. We also have component, so sometimes you have schools saying, oh, well, you've got a PC for $35, but we can't afford a bunch of HDMI TVs. And I'm like, yeah, go contact your local electronics recycling group, whatever's done by the government here, or the state or whatever, and say, hey, next time someone's throwing away a bunch of CRTs, can we have them instead of you scrapping them? And then you can just use your CRTs, and those are free. I mean, we honestly think you should be able to source everything that's on this board for free, right? When you get USB, SD cards basically given away, certainly at low volumes, you need 2 gig for this. CRT you can get from Craigslist or whatever, and a charger, micro USB charger. You probably already have your BlackBerry, or some old phone that you've probably put away in a cupboard, and a keyboard and mouse. Go to your local downtown financial institution and say, hey, next time you're, resupplying your IT gear, can I have your old keyboards and mice? It's amazing that they throw them away when there's, because it's just end of the cycle and they're perfectly good. So, we have seen people, and we do believe you can get everything you need for this, literally for $35, which is part of the mission. But the nice thing is, the reason why we have HDMI is because the idea is that kids can use this to replace their Xboxes, right? So, sort of
XBMC running. I have 5 different ones I've given to students with XBMC
right.
running on them. So it's 35 as opposed to like 120 for a Roku.
Yeah. So it's funny you said Roku. So this is the same chip.
Yeah,
I kind of
thought. Well, I do electronics.
Yeah.
So.
Yeah, it's the same chip as in the Roku. I'm pretty sure I can say that. So yes, you save a lot of money that way. It was really funny actually. So back in the UK, there was a computer users magazine and had a review of home cinema platforms. And this was reviewed as one of the commercial platforms, along with like the Roku and those other things. And they gave it like 4 out of 10 because they're like, oh, it's cheap, but it's not polished and doesn't come with a case or something. And we were like, I was like, do you know what? If we had an office, I'd have framed that, because I'll take that as the fact that we produce some hardware for education and the community's got stuff in a good enough position that, actual computer magazines can think it's a finished product. I thought that was kind of cool. So the kind of story behind this, I'll do the story bit whilst there's enough people here. So I'm Rob Bishop, so I'm from the Raspberry Pi Foundation. I'm over here from the UK. So the foundation, we believe, is probably one of the largest companies to have no employees. So we've shipped 500,000 of these. We're probably going to ship 1 million before our first year of shipping's up. And we have no employees. We've never paid anyone to do any work for us, which is kind of crazy, right? So there's maybe 5 or 6 engineers who work on this full time. No, sorry, don't work on this full time. They have full-time jobs, but work on this sort of executively on a day-to-day basis, but in their evenings. People often ask me if I'm a founder. So the way it kind of works is we have a bunch of trustees who a very long time ago realised that we needed a cheap computing platform for teaching education, realised something needed to be done. And they founded the sort of Raspberry Pi company and not-for-profit company, and went away to try and make a device. There's then a bunch of us engineers at Broadcom who actually sort of created this device, and we're the sort of founding engineers, as it were. So I'm one of the very original engineers to work on this. I don't know if anyone saw, like, extra bonus points if you did, but the very first time this was ever publicized was like a USB stick with a camera module on it. So the picture of that, which made it onto Engadget, was taken on my cell phone off my desk, which I'm quite proud of to this day. I did the original version of that PCB design, so I've been with it all the way since then. I now just basically do kernel, well, I say I do kernel hacking, but I basically now tweak for a living, which is kind of bizarre. I'm still trying to get used to that, but anyway. So the history of the project is our founder, Eben Upton. He now works at Broadcom, but before he worked at Broadcom, he was the Director of Undergraduate Studies over at St John's College in Cambridge back in the UK. And while he was there, he realised that the quality of the candidates he was getting applying for computer science was dropping, and the number he was getting was dropping. It's funny, I said that at Stanford, and they said, oh, well, we don't struggle to get computer science, good computer science applicants. And I was like, yeah, that doesn't terribly surprise me. But generally, like in the rest of the world, there, there's a bit more of a sort of drain. And he went away and he tried to figure out why this was. And what he realised is the problem is that my generation grew up with two kinds of computing device. We grew up with a sort of games console and a shared Windows PC in our home. Now, games consoles are phenomenally advanced bit of kit, right? Your Xbox 360 has better flop performance, better silicon in it than a 1990s Cray supercomputer that would have cost, tens of millions of dollars. It's quite impressive when you see them next to each other. I went to the Computer History Museum back in the UK and they actually have one of those Crays, and there was someone working on it. It's this huge beast of a machine, and literally all of the chips in that are less powerful than the couple of GPUs you have in your Xbox, which is kind of, in sort of 10 or 20 years, that's pretty awesome. But the problem is, although you have all of this performance, it's all abstracted and it's all closed. So, you don't buy an Xbox 360 based on what chips on it. Microsoft don't even really want you to know what chips on it, right? They just want you to know about the packaging and the games. You think the PS3 has really awesome performance. The Cell broadband engines are a phenomenal bit of silicon. But, GeoHot went away and hacked it to go and put Linux on it, and he got sued, right? It's not a great platform for going and learning. And when Eben was growing up, if he wanted to play a video game, he'd go to his sort of local newsagent, he'd find a magazine for computing, he'd find a game he liked the look of, get the source code, go type it in, and then he'd go and play his game, right? Whereas my generation grew up with sort of downloadable content where we don't even know where it came from. It's just magic, there's a game you can go and play. And the point is, even if you wanted to go and see how that game was running, you're completely abstracted. The game developers don't want you to know, the console manufacturers don't want you to know, it's all hidden. And for learning, that's no good. We're particularly seeing now, you're getting sort of a lot of kids, their first contacts with kind of iPads and iPhones and things, right? It's a great platform for delivering digital content. It's a terrible platform to understand how that was produced, or even to produce it. The fact that you can't make Android or iOS apps on the Android or iOS platform, it's a creative dead end. And that sort of brings the other problem with a sort of Windows PC that we all kind of, certainly my generation kind of grew up with. And the problem is, while you can go and develop in Windows, there's a barrier towards doing that in terms of cost or effort, where there's no barrier to opening up a browser and going and playing Flash games or watching YouTube, right? And because we're in a sort of instant gratification society, if there's no barrier to content consumption, and there's some effort required to go and create, no wonder the kids don't bother. When there's all of this brilliant HD content you can go and watch easily, or you have to go and battle with downloading Visual Studio somehow to go and write stuff in Windows, or Cygwin or something, no wonder the kids don't do it. And so, and the other problem with the Windows PCs is I remember when I was younger, taking apart our sort of home PC and a gateway PC and taking out the motherboard, and my dad coming in whilst I sort of had taking the fan off the chip, on the motherboard, and being quite annoyed because he couldn't go and check his emails for work the next day, right? And the problem is that, if you're reliant on your machine for homework, if you're reliant on your machine for playing games, if it costs you money, right, you're not going to have the freedom to go and mess around with it, And also, in particular, if parents have bought their kids a new MacBook for many thousands of dollars, they're not going to be very happy if they're taking that apart, right, because of the investment. So what we realised is what we needed was an additional device that was a toy. It was there for hacking. It wasn't something else you could take apart. It wasn't something you needed to be in a working state so you could do your homework. It wasn't something that was expensive enough that parents would be worried that they wouldn't know what their kids were doing with it, and they had a soldering iron next to their bit of electronics that they bought, right? And so the point was to remove all of these barriers and remove all the abstraction, and give them back a device sort of like the Spectrum, but so cheap that any kid could have one, and that parents wouldn't be worried about them hacking it. And Eben wanted to do this for a long time. As I say, he joined with a bunch of trustees to go make the not-for-profit to do it. But it was only whilst he was working at Broadcom as a chip developer, he realised that the state of mobile processors got to the point where actually he could make that device that was small enough and at the price point he wanted, because mobile processors are powerful and cheap enough that he could do it. I know some people are concerned about the openness of the GPU on this board, but our kind of response to that is, you know, we're not a bunch of guys who sat down and said, hey, let's get rich and have a startup and let's make a cheap computer. We're a bunch of hardware engineers and kernel engineers who said, hey, this development platform we have for this mobile applications processor, you know, we can totally cut that down and sell it at a much reduced price to make that cheap computing device for hacking that we always wanted to do. You know, it was that way round. It wasn't that we went about and went to go and choose a processor. It's the fact that we had this processor, you know, and this is the best that we can do, right? And the closed thing, the closed bit of the GPU is frustrating. You know, our ideology is ideally we want to be as open as possible. But if you want to make a board with a processor that's kind of less than $10, the only way you're going to be able to do that is if it's with a processor with volume. And the only way you can get volume on your processor is by having something people want to buy it for. And you know, you kind of have to make sure people can't copy it if that's the case. I mean, making this processor cost Broadcom sort of hundreds of millions of dollars in terms of, you know, everything from mask sets to paying the engineers and housing us all somewhere to do it. And you know, if they were to open it up, they can't then get the you know, regain the capital that they had to put in to go and do it. They then don't have the money to go make another chip, you know, and then the industry's broken. The truth is, if we want to make a truly open processor, a truly open platform for kind of $35 or less, what we really need is financial engineering rather than computer engineering, right? You know, it's things like the patent system and the way that these things are funded that needs to be looked at, not so much the engineering. But all of the CPU side, all of the userland stuff is going to be open source. We're going to open source all the PCB as soon as we can. You know, we're going to get this to a point where it's as open as we possibly can make it, but still ship. You know, ultimately, the thing we're most proud of is we've shipped 500,000 of these. You know, there are many great Kickstarter projects out there, but there aren't many who can say they honestly shipped 500,000 in their kind of first 6 to 8 months of trading, right? And that's a testament both to how much we were focused on getting out the door, but also to how much actually, you know, people needed this. People wanted this cheap device. And it's not so much that it's just a cheap device for kids. We're also seeing as there's lots of guys, sort of grad school, you know, older guys, you know, there's not a lot of money around these days, right? If you want to go and build those awesome robots you want to do, you can't really go and spend thousands of dollars for a computer to go and put at the heart of it. But certainly when I was doing my undergrad, there was loads of projects I wanted to do, but I simply couldn't justify spending my beer money, because you know it's pretty sacred, on going away and buying all the bits I needed. The point is that in producing sort of the brain of your robots, in producing the processing power, the GPIO for $35, you know, we've hopefully let lots of makers go and make projects that they couldn't otherwise afford to do. And ultimately, although our goal is education, we see the best way to inspire kids is by showing them awesome stuff, right? We don't think we're going to inspire kids by going in and giving a lecture and going, oh, you know, computer engineering is important because it's important for the industry and, you know, it's good for jobs and this sort of stuff, right? We think we're going to inspire kids by saying, hey, look, it's a webcam that tracks you moving and fires foam bullets at you. Isn't that awesome, right? And when the kids go, yeah, that's awesome, I want to make one, we're like, well, if you want to do that, you're going to need to learn about the programming, you know? Because ultimately, programming is a tool, computing is a tool. It was invented by lazy people who wanted to do things more quickly and with less effort, right? It wasn't invented as an academic pursuit, you know, it's not a Sudoku, we didn't just make it just to be challenging or to have something to optimize because we were bored in the evenings. You know, engineers did computing, they did programming because they're lazy, they wanted to do stuff quickly. And the thing is that we think this is not just a platform for budding engineers, not just a platform for scientists. You know, this is a platform for anyone who wants to go and be creative and, you know, can use programming in a way to do that more efficiently or more quickly. You know? And we think that's important. We think that we want to see this as a tool for creativity. Much like sort of people now teach maths by saying maths is useful because you will come across it in life, it is a useful tool. We want to say, you know, programming for anyone is a useful thing to have some knowledge of, because when there comes across a task that you could easily automate, when you want to make some art project with LEDs that suddenly using some kind of program to do that's going to be more efficient, you know, you have that tool, you have that extra sort of creative avenue. And that's why we're talking to Hackspaces right now, because we think the way to inspire kids is for us to go and make awesome stuff, you know, and show it off at Maker Fairs or Burning Man or just on blogs, right? And then, you know, go into schools or get the, you know, publish that to kids through blogs and things, show them awesome stuff and say, hey, you know, programming is a way to make awesome stuff. It's not just the thing for geeks, right? You know, you might be geeky for the people who do it, but the point is that, you know, we're doing just the same thing as artists are doing. We're being creative, and this is just a way of being creative. And, you know, we want to try and and fix some of the misconceptions and fix some of the gender imbalances by saying, you know, don't think of engineering as being science, think of it as a creative art, right? I can, if there are any sort of teachers in here, I can talk a bit about sort of our educational goals and stuff. There's always a very varied sort of audience, right? So I'm aware there'll be some hackers in here who are like, yeah, I've been a kid, I just want to make an awesome robot. And then there's also teachers in here who kind of, you know, are more just going, hey, what's this Raspberry Pi thing? So the people who didn't know anything about Raspberry Pi, do you have any more questions? Did I vaguely answer that?
Yes, thank you. That was good.
Cool. I'll pass the board round. But I mean, essentially, if you spend $35 on one of these, or $25 when Model A comes out before Christmas, you get the board, just the board itself. All you then need to do is get an SD card, go onto our website, choose a flavour of Linux you want to use. If you've never used Linux before, we recommend Raspbian. It's the one that we sort of officially support, but it's not made by us, it's made by the community, but we officially support, we do our testing on it. You sort of burn that onto the SD card, put the SD card into the machine, hook it up over HDMI to TV, plug in your BlackBerry or whatever micro USB charger, boot it up, and you get something that looks like you get something, well, actually I'll show it to you.
You just plugged it into a real Raspberry Pi.
Yep, so there's one of these running right here, right? So if you get Raspbian and boot it up, it looks like this. Now one of the interesting things about our sort of methodology, you'll notice this is booting a kernel. This is the same kernel pretty much that you're running in some ways on iOS, in some ways on your Mac, in some ways on Android, right? The point is that usually this is obscured by some nice graphic, right? The point is that we show you this because, okay, yeah, you don't need to know it, but we kind of hope that some kid's going to go, what's DMA? Right? You know, and with Wikipedia, you can go look it up, you can go see what DMA is, right? The point is we don't want to hide all that stuff. We want to go the other way. We want to go back to sort of spectrums and make everything accessible, but not accessible in terms of easy to use, but accessible in terms of everything is there. You can see it. So you'll notice this boots to a logon prompt in a terminal, right? In a bash shell script, right? It doesn't boot to a GUI. You can have a GUI. It's just a default login of Pi and password of Raspberry. It's on the download page for download. You can have a GUI. It says if you want a GUI, type startx, right? So you type startx, and you get something that's more like you recognise. The point is, there was abstraction to going and getting a GUI. You know, there's a barrier towards getting a GUI, and no barrier to programming in the terminal. I see good programmers, right, writing stuff in Python. They'll go, oh, I want to write my Python program. So they'll boot up the GUI, they'll go open a terminal window, right, and they go start writing Python. And I'm like, well, you just threw away 20% of your CPU overhead for nothing, right? What was the point? And so, you know, if you want to be lazy, as all the best engineers are lazy, and you type Python as soon as you boot it up, you get a, you know, a lot better performing Python script shell than you would do if you're running it through the GUI, and less confusion about permissions as well. So yeah, so this is a computer as you would recognise. We really like sort of talking on the briefly about the educational stuff. We like Scratch as an introduction to programming. Scratch is great because it teaches programming in terms of algorithms and in terms of data flow without ever needing to say the words algorithms or data flow, right? Ultimately, the way you optimize programs is in a flowchart. You know, if you're optimizing by the time you've written your code, right, you know, it's too late, right? You should have done that in the first place. And so, you know, the design of this chip was mostly done on whiteboards. You know, as anyone who's worked on big software here, right, most good software is ultimately mostly a flowchart and syntax added to it later. Scratch teaches that, right? You go and make something in terms of, you go and select some like control thing, so you're like when, there's a control, everything's got the right names, you've got operators and variables. You don't need to know what those words are, you could just use the colours, but the point is it's, you know, it's accessible, we're putting the right words there, you know, we're not hiding it. I mean, we don't make this is made by MIT. So you can have like when the flag's clicked, loop forever, move 10 steps. And you'll see all I've done there is drag and drop, let me get that in the right place. Drag and drop blocks, but this is basically a flowchart. You know, this is an algorithm, but you don't even need to say that. And then press that, and the cat does something, right? not very exciting. But the point is that we see. I've seen 7, 8, 9-year-olds go and write stuff in Scratch, and these kids, all they've ever done is they've consumed apps that people have made for them. Right? For some kids, this is the first thing they've ever actually made on a computer. And the point, which isn't like a word processing device or something they could do with they could do without a computer anyway, right? And the thing that's great is we saw some brother and sister, and one of them went and made a game, and the joy at seeing the other one go and play the game they've made. I mean, kids are creative, right? The point is you can very quickly go and make games. You can change the cat to like a rocket, you can change the background to space, and you can make a little game of asteroids or something in not very long. And it's really cool that you can get kids very quickly making stuff and thinking the right way. And we're hoping that when they then do move on to Python, I'll do what I shouldn't do, which is launch Python in a terminal, but don't do this. But you can do it. You can't type it. The point is when you move into Python, what I hope the kids are then thinking is, okay, I want my program to do a when and an if and a loop or something, and then what they're doing is they're putting the syntax, those blocks in their head, they're matching the code to the flowchart, rather than, we get coders where they just sit down and just start writing, and you think that's never going to be a good bit of programming, right? We like Python as a teaching language. The reason we like Python as a teaching language is, if I can remember the keyboard layout on these things, right? That is one line to do your hello world. Well, I just put hello there, right? Try doing that in Java. It's about 600 lines, right? Python's very powerful because it's a very great language for getting stuff done. It's why it's used by the scientific community. If you want to very quickly automate something, if you want to very quickly make something, Python is a great language for it. It's also a great language for teaching because you can use it with an interpreter, right? So your kids can use it just as a desktop calculator, or anyone who's learning Python, right? You can just use a desktop calculator. You can just try random commands and immediately seeing them working. You don't have to wait for compiler, you don't have to deal with compilation errors. You type something, something happens, right? It's also really nice for basic debugging because you can literally type in each line of your code one at a time and see if it did what you're expecting. It's like a step-through debugger just in an interpreter, right? And this is a great way just to introduce kids to syntax, making stuff happen. With the GPIO libraries on this board, making an LED light, one of on-board LEDs, making an off-chip LED light by GPIO, making a motor move, is one line of Python, right? That's pretty cool. So you can write a couple of lines and make a simple robot. It's pretty awesome. You can then take those lines that you've done individually, put them in a short sequential block, compile them as your first program. All you have to do, you learn about compiler, you learn about how to write something, learn about compiler, that's cool. Obviously, anyone who writes Python seriously here, Python's an object-oriented language. If you want to write good Python, it needs to be object-oriented. The point is, if you're learning Java, you need to go away and learn about class hierarchies, go and read your object-oriented textbooks before you write any code. Nice about Python is you've already looked at algorithmic development, you've already done some programming, you already know the syntax. You're in a good point to go and learn about object-oriented programming, to then go and do that. You're not having to, we're not going to have much success telling kids they need to go and learn a whole bunch of materials before they can ever write any code at all. And if you try and put kids on Java without teaching them any object-oriented design, have fun explaining why they're at Hello World 700 lines, right? And so we think that's a good progression. The other, obviously, if you're doing kernel development or any kind of serious programming, quite often you're going to be in C. C is a great language. It's not a great language to introduce people to. It's not very human readable. You need quite a lot of in-depth knowledge to write good C. The best way to write C is if you know the hardware you're writing it for, and the best way to do that is to learn assembly. So we actually suggest if you want to learn C, go and learn assembler first, right? Then go and learn C. Anyone who writes C in here will know it's basically just macros for your assembler anyway. If you have a good knowledge of the assembler of the platform you're working on, you'll write so much better C than someone who doesn't, right? Just because you at least know what it's going to do. C is a low enough level language. If you want to optimize, you're optimizing on a hardware basis. There's no JVM. You're optimizing for the platform you're running on. And the best way to know the platform is to go away and program on the atomic level of the platform. In order to do that, there's a course available from Cambridge University called Baking Pi. It's a free course. It teaches you how to write an operating system from scratch in assembler, complete with frame buffer, right? There's quite a few people who professionally work in IT or computer science who will never have written their own operating system, pretty much not in assembler, right? So we think that's a really great course. I mean, I still find that course interesting. It still taught me stuff I didn't know. Right? It's a good course. It's written by Cambridge academics, so it's it's very trustworthy in terms of its content. That's awesome. Is that like a and it's available for free online. And anyone who wants to learn C, go and do that course first, then go and learn the C syntax, and you write much better C. Talk to anyone who's a kernel developer, and they'll tell you that's true. Alright, so while I was in, slight bit of bragging rights, whilst I was at Google, so I gave a Google Tech Talk, which is going to be hosted online in their Tech Talk series. And whilst I was there, I was talking about the joys of C to the audience. I then went for sandwiches on the Google campus with some of the guys who were there. And one of the guys who was there was sort of a middle-aged guy, quite long, kind of greying hair, with an impressive beard. And I was talking to him about C, and I asked him what he did at Google, and he said he was retired. And I said, oh, I think that's kind of cool. I said, well, what did you used to do? And he said, oh, well, quite a few things. He said, I helped write Go. And I didn't think much more about it. I meet a lot of people. I went home. I thought, hang on. I know the guy who wrote Go. Go and look it up. It's Ken Thompson, who, of course, got the Turing Prize for not only inventing Unix, right, for doing most of the development for C. So I was slightly humiliated that I'd gone and told Ken Thompson that Unix was a good platform and C was a good language to write in. But you know, at least you know, he shook my hand and said he's got a Raspberry Pi too, so we can't be doing it too badly, right? Yeah, that's one of those things I'm going to be forever ashamed of. There's so many questions I could have asked him, and I was talking to him about like what we were doing. And I was like, yeah. So yes, I'll answer some more questions. I've sort of lost my train of thought now. I'm too humiliated by the Ken Thompson.
Do you know if anyone's gotten Mint or one of the distros that you can run Arduino on working on that guy?
I don't know. So we have a lot of distributions which run on this. So we don't have. So the distributions which don't run are normally because they don't have support for the v6 instruction set. So for example, we initially were using Ubuntu, but Ubuntu dropped support for v6, so we can't do that. The Raspbian is a fork of Debian. Obviously, any open source developers in here, you know, the number one rule is don't fork unless you absolutely have to. The reason we had to was because Debian has two distributions. One is for v7 with hardware floating point, it's like kind of latest and greatest. And then they have a sort of catch-all, there's a v4 with software floating point. As you can imagine, the performance gains on moving from a v4 instruction set to a v6 and from soft to hard floating point makes it worthwhile. So that's why we did that. It does mean that we haven't yet rebuilt, well, I'll say we, the community that does it, haven't yet rebuilt all of the packages. So there are still some packages missing from Raspbian. There's a forum post. If you go on the forums and say, hey, I'd like to see this package, they'll go set it up to go and build it. You can, of course, build it yourself. You know, the GCC tool chain's there. You know, there's nothing closed about building stuff to run on the ARM. So I'm not sure if Mint's based on Ubuntu, right?
You can't get Mint.
So yeah, so it will be 6.
Like 2 days.
Yeah. So someone actually submitted a bug report on the official Ubuntu sort of launchpad bug tracking system saying doesn't support Raspberry Pi, which we thought was quite good. Not really the right bug report, but still kind of cool for us. We're still talking to Ubuntu saying, hey, why are you not supporting v6? That's right. Debian, however, is obviously a great platform for development. The Raspbian is as fast as you can get it to run on this. People who use Arch, I know developers quite like Arch. The Arch on ARM guys, I went and spoke to the other day, the build for this now is hardware floating point and v6 as well. So the Arch build, I mean, the kernel size that you're running has some impact on CPU overhead. CPU overhead scales with the size of the kernel you're running, so the number of modules you booted in. Obviously, Arch, their philosophy is to go for a minimal kernel and sort of minimal original libraries and distribution. So if you are doing serious development, you'll probably get the best performance out of Arch. If none of that makes sense to you, don't use Arch. Right? You know, unless you know you want to use Arch, probably don't use Arch, because it's just going to cause you pain when you don't have any dependencies you want.
For Raspbian, what's the upgrade path? Is it each new distribution should replace it completely, or do we gradually do a, apt-get upgrade?
Yes. So we release new images periodically. The images we try to make are as stable as possible, right? So that doesn't mean they're the latest code. It just means it's probably the most tested code. So in some ways, they're probably going to be quite old, right? The state of development with 500,000 users in the community, right? We change those fairly infrequently. And just as an aside, anyone who's interested on the development status, I set up a Twitter feed called RPF Dev Updates, which is basically an automated Twitter stream, which tweets every time we make a commit to any of the firmware, Raspbian, or kernel repositories. We also tweet anytime we update the official image, and we tweet anytime we add new packages to the repository. So if you don't want to spend ages sitting around looking at GitHub or getting loads of emails, if you follow that one Twitter feed, that basically has all of the nuts and bolts of what's going on. You know, it's not meant to be a sort of beginner's update thing. It is like it's commit messages. But the point is, if you are a developer and you're waiting for something particular to come through, that's a good way to stay on top. Because I know there's some sort of more experienced developers saying, hey, I want to do X, and you're kind of not being very transparent on it. We're probably not very transparent because there's 5 or 6 working on this, and as I say, you know, like writing the blog post about what we've done comes like sort of after we finish doing it. We've still probably not finished doing any of the things we set out to do when we started selling. So the Twitter feed is probably the best way to track literally what we're doing, because you can see that by the commit messages. Going back to your question, so I don't know how much of a Linux user you are. There's a thing called a aptitude repository, and basically we have our own repositories for Raspbian, for our fork, with all the pre-built debs for hardware, floating point, and v6. That also includes the firmware and the kernel edge. So if you do an apt-get update and an apt-get upgrade, to update all the links to where all the mirrors are for all the debs, the binaries, and upgrade basically looks at all the debs, the binaries you have, and puts new ones on. So if you do that,
I used the July one, and I just got the September 18th one.
yes. So if you so we would recommend if you regularly do sudo apt-get update. I do it on here, but I don't have networking, and you can string those two together and do apt-get sudo apt-get update ampersand apt-get upgrade, and that'll do all the more
It would be just as good as if you download the fresh one.
It'll be more up to date
Okay.
and pretty stable, right? If you want if your life depends on it, which if anyone's life depends on Raspberry Pi, I'm kind of worried, being one of the engineers who worked on it. But you probably want the images that are on the hosted as images, right?
Yeah.
If you want, you know, to get the latest stuff that we think is good, right? Then pull off the repositories. If you want the absolute bleeding edge, well, if you want the reasonably bleeding edge, there's then a bleeding edge repo in Raspbian, which is the stuff that hasn't been tested enough to push it out onto the general repo. And then if you want the bleeding edge, there is a tool made by Hexa, which is called RPi Update, which basically just builds the binaries and pulls them off GitHub. So it's like anyone who's an open source developer, you know, pulling off GitHub's like a nightly. It's more frequent than a nightly, but you know, it's literally the very latest checks. You depending on when you do that, you could well get code that we haven't even tested yet. So you know, have fun with that. The bleeding edge in Raspbian is sort of like the release candidates. Anything which is in Raspbian is a release, and anything that's an image hosted on the website is like a last known golden stable. But yes, you do update the firmware when you do an apt-get update. So some people get confused. I didn't. I got confused at the very beginning.
Do you have what is your plan for the next platform? What do you have in mind?
So one of the things that people probably know kills startups is when they have a bit of success and then go, hey, this is great. We can now do all the things we wanted to do. Right? We haven't yet got these in loads of schools. We haven't yet got the sort of science foundations and educational bodies to write the lesson plans for this, or for some other cheap computing device. You know, we haven't yet succeeded in our mission of getting school education better.
High schools that are waiting for me to write a curriculum for that.
Awesome.
But I can't get more than 5 at a time.
Yes.
They have classes of 40
Yeah.
plus children.
So
they're both waiting.
So talking about the lesson plans. So just answering this briefly. So basically the point is we want to get this polished enough, get a education ready platform done, get the educational materials written, and do all of that first before we start thinking about other platforms, because that's what we set out to do. Answering your question, what we're trying to do is, obviously there's sort of 6 of us sort of executively working on this, right? And none of us are educators. You know, we're not arrogant enough to believe that just because we can do something, we can teach it. We think that is very much its own skill, particularly if it's the first introduction to programming. You know, when you have these sort of PhD engineers, sometimes it can be really hard to, and so we don't think we're the right people to do that. We see that our strengths, the thing that we can do is make the tools. The education bodies couldn't make a computer as cheap as this. We can do that. We'll focus on that. We want to work with the people who are skilled at making the materials to do that. So we're actually going at it from the top end, simply because there aren't enough of us to go and talk to all us, individual schools, right? So we've sort of got a two-ended approach. So they going from the grassroots. What I'm hoping is that, and I've seen as I've gone around the US, and as I go around the UK and Europe, I meet teachers, educators like yourself.
I'm not actually.
Well,
I'm trying to become
yeah.
one.
Well, okay.
I'm trying to bridge the gap.
Yeah.
Because when I sit there and have to take 10 minutes to explain to a teacher what a chipset
Yes.
is, and it's like, I don't think she
Yeah.
understands like what a Raspberry Pi is.
I mean educator and not necessarily just people who are paid to do it. I mean the
Yeah.
people who are on the ground level going out there and talking to kids, right, and have some experience in that. Those kind of people, we're ready to say, hey, we have a platform. Because those kind of people like yourself, they don't need lesson plans, right? They needed something to come along and do this, so that they can make Arduino style projects for cheap, but using Python rather than having to go straight into assembly, right? That's what we've done. So a slight aside talking about Arduino. People often say, oh, are you trying to compete with Arduino, that kind of stuff, right? We didn't sit down with some VCs and go, where's our market sector? How are we going to profit, make profit from this? We went, hey, that'd be a cool thing to do. Why don't we do it? Yeah, okay, right? That was pretty much the decision-making process. We in some ways, if some other company came out with something that was cheaper than this and higher performance and more open, that's great. We'll all go back to our day jobs, right? Ultimately, we think this should exist. We think that it's important to get cheap computing out there. I think it's important to get physical computing accessible. We did it because we saw no one else was doing it. We've done the best we can do. If someone else wants to come out and do our job better than us, that's fantastic. We're trying to make that happen. The thing which gives us the most pride is the fact that if you go and read The Verge or Engadget, it's full of, or even Kickstarter, it's full of projects that are Raspberry Pi-like, Raspberry Pi size, Raspberry Pi price, right? And we hope that we've inspired people to say, hey, look, we've sold 500,000 of these. There is some market in it. Please go and see what you can do. If we were seen to be competing or trying to take out other consumer hobbyist electronics companies, that'd be a travesty. We absolutely don't want to do that. We think there's still a place for both. The Arduino is great if you want to do any kind of sensing projects, if you want to be really low power, if you just need a microcontroller, that makes sense. Where this makes sense is as soon as the programming gets to the point where it's so complicated, Python's going to be faster to do it. We think as an introduction to programming, Python's a lot nicer than doing assembler or some version of C. We also, I believe that if you want networking with an Arduino, by the time you buy the relevant shields, it's like over $100, whether this is everything for 35. So, we think they coexist. We think there's a need for both. We think as an absolute first introduction, this is a nice catch-all. The point is you can give this to your kids. They can run Scratch. They can then go and do the Arduino-like GPIO stuff. They can go all the way up to doing networking or stuff using the GPU. And the point is, it's everything in one platform that the kids can own for $35. They don't need a PC to go and play Scratch. They don't need an Arduino to go and do the low-level stuff. It's everything in one package. The other thing we really like at the price is we see a lot of what we're trying to encourage to do with schools and charities and things is this idea that at the moment kids come into the classes, they'll maybe go into a classroom full of PCs, set up with all the appropriate software. I don't know if this is something that relates with you. They'll go and do their class, then they'll go home, and then they'll have to try and convince their parents to let them install whatever software and whatever PC they're using, right? The thing is, with this for $35, what we're kind of hoping is that the kids can go into a classroom, start their projects, then take them home. And then they just plug it in as they plugged in their Xbox and keep going. Everything's already there. We're removing that barriers. Anything that makes it harder for the kids to go and learn, is something else that's going to convince them to go and play Call of Duty instead. So we want to try and remove those things.
Heads up, by the way, we've got food for y'all when you're at a stopping point.
Dude, that's awesome. I'll just quickly answer this, and then we'll do that. So, basically, we would love to help you. What we're trying to do right now is get people who have been doing teaching with this, blogging about it, writing case studies. My Twitter feed is full of links to other sort of single groups. So if you think about it, as I've gone around the US, there's lots of dedicated people who've gone into schools, and maybe one high school has a classroom with Pies, maybe another high school in some other area has teaching something else. It'd be really nice as if we could get those people to sort of share stories, work together, do that kind of stuff. That's at the low level, and that's what we can do right now. in terms of a sort of more grand vision, the worst possible thing is if schools went, oh, Raspberry Pi, that's trendy and they're cheap, bought a ton and they just were getting dusty on a shelf because teachers didn't know what to do with it. Right, that'd be tragic.
Well,
Right?
that's kind of what,
Yeah.
that's what I see would happen if
Exactly.
they don't have somebody that
Exactly. And so what we're doing is we're working right at the top on the government level. We're talking to a number of exam bodies. I mean, mostly back in the UK, because the UK is obviously a good test market, because it's a lot smaller. There's sort of fewer levels of bureaucracy to get through in terms of national rollout. But we're talking, particularly in the UK, with the people at the government level who decide the curriculum, who decide the teaching plans, and get teaching sort of lesson plans and teaching resources available in exactly the same way as a teacher might get their algebra courses, might go and get their Shakespeare courses, right? We want to have it at the same sort of level. And we don't want a class for Raspberry Pi. We want, a class on physical computing and computer science using Python that you can do on a Raspberry Pi for cheaper. This isn't something we're driving so that we suddenly find that, the dependence on the Raspberry Pi for their IT education. We're just trying to make sure that the IT education aligns more with what sort of Cambridge academics, who I'm not going to argue with, say we think we need and think it should be, and that they can use a $35 platform rather than a sort of $1,000 Windows PC. And that's what we're trying to do. As anyone who's worked, you probably agree with this, who's worked with sort of bureaucracies of very large government bodies, that takes time, right? We started the conversations a long time before I got here. We'll probably still be doing them a long time after I leave. We're doing our best, but the worst thing, as I say, is if we push this out now and got dusty, or if we burnt our bridges with the education community because they said, oh, well, there's no resources, I don't know what to do. So we're not pushing it there yet because we're not ready. We've got, off the back of 500,000 units sold, we have enough funds to sort of take it slow, play the long game and focus on a mission. But on the sort of lower level, I'd love to maybe talk to you afterwards about what you've been doing, see how we can help, see if I know other people who are doing similar stuff, because we'd love to do that.
one of my issues is I've been very busy doing and I haven't been documenting.
Yeah.
So,
Well, it's exactly, yes, it's exactly the same as us.
What I do now,
Yeah.
because I just don't have the time.
So there's a class in DC that's just run they're now doing I don't know how the funding works in the US, but they seem to be able to do their own curriculum. And they're doing a IT curriculum based off Raspberry Pi. Someone's granted the school with a bunch of Raspberry Pis. And they've had awesome success. They've had really high turnouts to IT classes and things. And the guy's been blogging about that. So maybe I should put you in contact with him and you can share ideas and stuff. But we'd love to support that. But what we're not ready to do is give it to the hands of sort of unskilled teachers. We're ready to give it to people who know already how they could teach it to answer the questions. We don't yet have... if we want to get widespread adoption, we need to have lesson plans in the same format as teachers are used to. We don't want them to have any barriers to overcome,
Well, yeah,
right?
they don't want to read the curriculum, they want you to. But
Exactly.
when you're the engineer, it's like,
Yeah.
I don't know how to
Yes.
teach.
Exactly.
I
So
just
we
know
are
how to do
we are
it.
working with the people to write the correct curriculum, but that is just going to take time. And I can't tell you how long it'll take. We're doing it as fast as we can. I mean, like bureaucrats, lawyers, and accountants, right, are the people as an engineer you never want to talk to. In this project, I now spend most of my time talking to those people. I mean, you guys should be very grateful for how much talking to lawyers I did on this project. I did this for you guys, right? I'll take beers as donations. So yes, we're doing our best. Cool. Okay. Well, should we grab some food if that's available, and then I can answer some smaller questions and things.
Food's all ready to go.
And we'll do some hacking and stuff because it'd be good to actually do some hacking. Like, I'm conscious that as an engineer, sort of me talking is all well and good, but I'd rather be making stuff.
They just go to sleep.
Yeah.
Did they
Just a
just turn off
screensaver.
the screen, or did they, the whole thing just shut down? Do you know?
I don't know. I haven't power profiled it.
Because the guys were saying that when it does that, it turns off the screen. Doesn't it?
I honestly don't know.
Hey, Rob. Question for you.
Yeah.
Have an 8 gig drive SD card.
Right.
Having a heck of a time repartitioning.
Right. That's probably because most operating systems, what they do is they create the disk image in RAM, and then they'll burn it onto your disk.
Okay.
So I bet you have less than 8 gig of RAM. So the problem is you then don't have enough storage to store the image. I bet it's not smart enough to create the image instead. Because let's say, so if you're producing a binary image, it's literally 8 gig. An 8 gig partition is an 8 gig block, right? So you're probably making the partition, storing it somewhere, and then trying to reprogram it. So that's
Because
probably
it can be done on the Pi itself, can it?
possibly.
The partition.
What you probably need to do, if you use a partition tool that does it smartly, I don't know what you're using, but there's a possibility that's why. I've seen that before. It's just because it doesn't have enough RAM to hold the partitions in its memory, so then when it tries to write them, it can't do it. You just need one that does it sort of step by step on the system.
What do you recommend?
Are you using a Linux system?
No, we're actually doing it on Windows.
Right. So that's probably your problem. Use.
That's why I was asking if we could do it on the Pi itself.
Yes, you could do it on the Pi yourself. It will take a long time, but you could do it.
And it's
Alternatively, you could burn a live CD. I'm pretty sure someone in this room would almost be able to give you one or make you one. Get a live CD, run that, use gparted, and it will all work nicely. Tool called gparted,
Yeah,
which does partitioning properly. Windows also doesn't understand the right filing systems, which doesn't help.
Wheezy.
Yeah, so use a Linux filing system. I mean, I'd always say go and use Linux on your home PC anyway, or at least have a partition.
Okay.
Because if you want to do anything like this, it's just so much easier.
All right. Thanks.
It's why development's done in Unix, because as soon as you need to get something done, Windows tends not to be very good.
So can we buy one from you now?
Right, so on the selling them today, right?
I think that's what we're all looming for.
Yeah. So I wanted to sell pies in this tour, so I go to the accountants. Again, you'll see a theme here in my frustrations. And I say, hey, I want to sell pies in the US. I said, yeah, you can do that, but you're going to have to pay import duty. I'm like, that's okay, I can pay import duty. And they said, yeah, and you're going to have to pay sales tax, and that's going to be different in all of the 5 different states you're visiting.
Oh man.
And you'll have to register as a sales tax, vendor or whatever, for the financial year for each of the 5 states you're visiting. And I was like, okay, this isn't fun. This is why I became an engineer, not an accountant. But I can do that. Go and try and register. Can't register without being a US company or having a federal identification number. That's $900. So the end of the story is we obviously have no margin. There's no profit. We're not for profit. So it's not like I could eat into the cost. So I'd have to add it to the cost of the taxes and the registration and stuff. So it would end up being like $40, $45, $50 or something by the time I added it all up. Alternatively, you can order from MCM and you get them in 2 days for $35. So that seemed to make a lot more sense. So sorry for that, but it's like one more day of waiting and you get it for $35 rather than paying a load more.
And it does work like you said. I bought one last week and it's just like that.
Yeah, we do legitimately have stock in North America. It's 2 days shipping, I think, to California. So
Yeah, from Newark it took us about 3-4 days.
yeah. So if you order online today, you'll have it by the end of the week. No, wait, what day are we on? Yeah, have it by Monday. Okay. I get so confused on dates and times, right?
What software did you use to lay out the board?
We used. So I didn't do. So the initial prototypes of this were basically Broadcom development kits cut down. For that, we used Synopsys tools, like professional PCB stuff. It wasn't Eagle or anything, right? It's very expensive. We used Synopsys OrCAD tools.
OrCAD is Cadence.
Yeah, Cadence.
Cadence,
Yes.
was it Allegro?
Yes. But I don't know what this was done on. This board was designed by one of the trustees who runs a PCB design company.
I guess all the boards are like the same.
Yeah, so that one's like a 2-layer, I think, whereas this one's a 6.
Fan logic.
Yeah, so this isn't made by. I didn't talk about those things. I'll talk about those things after. But basically, this is a Gertboard, this is a camera. This isn't made by the foundation. That is. That's a prototype.
I was just wondering if there's any testing that you guys did for longevity of having it plugged in 24/7, longevity of the board.
The connectors, all of the components will have had their own testing. So the thing to do is to find. I think they're all Foxconn connectors. So find the part, and they will have to publish a mean time between failures or something. So that's the way to do it.
No, I mean the actual before the actual CPU starts.
Oh, the CPU.
Giving issues.
This is in mobile phones, right?
Yeah. So it's running.
That'll last longer than you will, I should think.
Okay.
Or 2 years and then you throw the phone away and buy another one.
Yeah. I mean, the thing you forget is this board is only for this, and it's only sold 500,000. Even if we sell 1 million of these, this chip is in cell phones where 100 million is an average run, right? So, the chip itself is pretty well tested. It's also, people talk about cooling and things, like your phone doesn't have a heatsink or a fan, right? Unless you're doing something crazy on the overclocking or running it in an oven, you don't need cooling. Electronics gets hot, go touch your MacBook Air after decoding 1080p video. It's designed to run those kinds of things.
I know you guys officially allowed the overvolting and over.
Yeah, so the official overvolting is limited by. I can show you. The overclocking. Again, I'm breaking all my overvolting, but the overclocking. You run the Raspberry config thing tool that runs on your first time you're on the operating system. It gives you a bunch of overclocks.
That's a 320.
You can go from non, which is the nominal 700,
So that's the
all the way through to turbo, which runs a gig. This has a fail-safe cutoff. There's a temperature sensor on the die, so it actually steps it up. It won't run at a gig constantly. This is the maximum your CPU will ever run at. It looks at CPU load, it scales up the clock frequency and core voltage based on load to whatever you specify. Bear in mind, if you overvolt it, you need more watts because you're, so you will test your power supplies. Your rubbish cheap power supply will almost certainly run at 700 megahertz with a keyboard and mouse. Right. Once you start using your USB aquarium and running it at a gig, right, you might start needing a decent power supply. But we kind of envisage that if you're overclocking to a gig, you probably own a multimeter, and if not, you should do. Shame on you. So, yeah.
Is that still an issue with turbo bump, SD card getting corrupted?
We're not sure. We haven't yet worked out whether or not there is a genuine correlation. There seems to be some evidence there's a possibility of maximum overclock that some SD cards are more likely to be corrupted. But we haven't done it. There's 6 engineers working on supporting this, right? So we haven't got any official proof that that's the case. We've just to be safe, we've limited turbo to 1 step less. It's still 1 gig, but it's slightly less overvolted. We think it's something to do with one of the memory parts is there's not enough slack when you up the clock frequency with the SD RAM clock frequency. So I think this is limited to like 495 instead of 500 or something. We're looking at it. We need more data. We recognise there's a potential. But I mean, it's, if you're overclocking to a gig, then, hopefully you're not using it for anything you're absolutely depending on, and so you might have some issues. And ultimately, like for 50% extra performance, the slight possibility of corrupting your SD card, which you can basically reformat anyway, hopefully isn't, it's a reasonable thing. I mean, you can get these running at 1.2 gig, right? Whilst I'm not officially saying on camera. You've always your warranty. Cool.
Is there a way of adding off-the-shelf RAM, more RAM on?
Not unless you have like a $250,000 pot placement machine.
And if you do you have drawings to do that?
If you do, you can do it straight off. The problem is you're then going to have to buy the RAM, and that comes in bulk orders of like 100,000 units. So, it's going to cost you quite a lot of money to go and replace that RAM. No, the reason why this RAM is cheap is because it's the RAM that's in cell phones. Obviously, cell phones, it's important to make them as small as possible. So, it's not an easy to assemble part. The primary drive for cell phones is not repairability, right? As soon as we can go for 4 gigabit part instead of a 2 gigabit part and still be under $35, we'll do it. The memory market fluctuates fairly wildly. I couldn't tell you whether or not that would be next week or like next year, but when it does, we'll do it.
Is there good for it?
Yes.
Can I ask about you said there's like 6 guys that are doing this, right?
Yeah, so I'm the least senior. Well, I'm the least experienced by a significant margin, but almost. So the cool story about me, right? So I was an intern at Broadcom. I've been an intern past 4 years whilst I was doing my undergrad and most of my graduate degree, which I'm now not finishing. And whilst I was there, I reported to Eben. Eben said, "Hey, we can totally turn this development board into this." And Broadcom said, "Yeah, you can do that, but you can't spend the engineering resources on it." Of course, the great thing about being an intern is you're zero-cost resource. So I did a lot of the really cool work on this. So I did the Quake 3 port, I did the original version of this PCB, I did the very first kernel ports. I do some of the kernel support now. But it's always been like, I'll come back over summer, do a big chunk of it, go back, and then come back again. The other developers who are working on it are all very senior guys. Almost by virtue of them being so senior, they're kind of too expensive for the foundation to kind of hire. and they don't have enough time to go do lots of development. So I've taken on a lot of responsibility very quickly, just because I actually have the time to go and do it.
So I guess I'm wondering, since it seems like you're constrained by the amount of people that you have,
Yes.
that if there was a way of somehow organizing it in such a way that many people could volunteer.
The problem is that a lot of development, which is the bottleneck, is on the GPU. To use that, you need an NDA with Broadcom. You know, unless you are some significantly large business, Broadcom legal just won't bother because it costs more money. You know,
That's a shame.
to get the NDA signed costs a fortune. I mean, it's the crazy. I don't know. Sort of off the record, it's a crazy situation we've got to with patents and legal. I mean, the lawyers must just be laughing, right? Because that's the problem.
Okay. It's so inspiring.
Yeah.
It's so, I mean, I'm sure everybody here is like, oh God, I'd love
Yeah.
to work on that.
No, I know,
you
I know. Well, yeah, I agree with that sentiment. You know, I dropped out of my masters to go and do it. But yes.
Thank you.
Thanks.
For doing this.
We don't have to. I mean, I'm quite happy, right? You know, I got to go and give a talk at Google at 22, right? So I'm quite pleased. Yeah. The flip side of that coin, right, is that I'm writing the software for the camera. So when 500,000 people get my open source code, and then I get all the bug reports, like with 500,000 people critiquing my work. So you know, like, I love the clock. There we go. Cool. People can come and play with this one. There was a young guy. Dude, do you have a Raspberry Pi? No. Okay, come and play with this one. Where's who? Dad?
Yeah.
Yeah, come and have a play.
Okay.
Like
You know-
this
you
is
know
who it's
Scratch?
designed for, right?
Yeah, you know how to do Scratch? Go do some in Scratch.
Exactly. I don't need to convince you.
Duck on through. Yeah, that's it. I think you and me are in the right.
Real quick, is there like a vanilla distro that goes out? If so, what's on it? Is Scratch part of it?
Raspbian, yeah. So the
Scratch
default
is-
image of Raspbian has a Wi-Fi configuration. It's this.
Okay. And is there development capability like that?
It's Debian. So yes.
Scrap that bogus.
On board?
Yes. I've been doing
I've been itching to try like and Ubuntu on this.
Yeah.
If
So you
it
can't
will
get
work.
Ubuntu because there's no V6.
Everything I'll do on it.
What you need to do is go and send lots of angry emails to Ubuntu saying, "Why did you drop V6?" Yep.
Depending on the order that we plug things in, power versus HDMI,
Yes.
we get different resolutions.
Yes. So the HDMI part of the spec is its hot plug detect. So the TV actually tells the GPU what it is.
Okay.
So if you boot it up, obviously the kernel then goes through all the steps of auto detect. I'm not sure whether or not it always reruns it when you connect it. So depending on when you plug it in, you might have already missed the point in the kernel booting where it's gone to detect and hasn't detected anything. So it's probably done. You probably find it's lower resolution than necessary. It's probably just defaulted to the standard mode, and then when you plug it in, that's what you get. The simple answer is plug in the HDMI stuff first, so when it does the right bit in the kernel process, it'll see it. Otherwise, you can, so if you do kernel stuff, but you can go back, it boots in stages, different run levels, you can go back to that run level and redo the end. Or you can directly kick the TV service to do it. Yeah, poor HDMI cables. It's like the USB, right? Cheap stuff, your mileage varies. Cheap HDMI cables, some don't support CEC where they should, some don't have the hot plug detect, some just aren't shielded well enough.
What's the laptop? It's coming up in low res.
Earlier you were saying that it wasn't it wasn't a great use case to like cluster it, but you said something about it's better to go to distributed.
Yeah, so it's never going to make a good supercomputer, right? What it is as an interesting use case, it would make an interesting use case in terms of distributed computing. So this idea of having multiple cheap computing devices, multiple boards, that you used some high-speed mesh interconnect, like SPI with switching, to do the remote procedure calls over. That's interesting, and that would be, like, that would academically be interesting in terms of a research project. So, yeah, if anyone's doing a PhD, if you're doing a PhD, go with that. There's professors at the University of Maryland and Colorado and Stanford who probably sponsor you on that. So.
Have you seen the 64 Bramble Pi, the Bramble that they've made over in the UK?
Yeah, so that's what I'm saying. So they use, I mean, they did that more as an example. So the one thing is, I mean, they have frustrating calling it a supercomputer. Like, it's got less power than a graphics card.
It doesn't do anything.
The second problem is they do the remote procedure calls over Ethernet, and the latency is horrendous. I mean, it's just not efficient. And also, with a monolithic kernel, I'm running a networking stack. You're using most of the CPU overhead of that, right? If you use the SPI with a microkernel, the SPI module is really lightweight. You know, you're not paying your CPU overhead. It's a lot faster on latency. Us engineers back at Broadcom, we all said we'd do it if we had time. But the one thing we absolutely don't have is time. That's awesome. These switch to costumes, you can make it like change what it looks like. So you can select like different things. I think. I've had to learn Scratch whilst doing this tour. So I always used to say you should use Scratch, and then one time someone said, "Oh, can you demo it?" And I realised I had absolutely no idea how to use Scratch. That was kind of awkward. So I don't write in anything other than C. I don't really write in Python.
So in other words, do as you say, not as you do.
Yeah. I was saying that with the Google guys. So like Python's great, but if you ever go and do a big project in it, and then for developers, they'll kill you.
I've heard there's a really cool computer called the Raspberry Pi that teaches you how to learn computers. I'd recommend grabbing one. Oh, that's just playing around. Do you find yourself learning more stuff about computers in general the more you use the Raspberry Pi? I know that.
So the problem is I don't really use it anymore. Right? This is the thing. I spent a lot of money on education, which is now spent on tweeting. But you know. So I was going. I was going to go and do a PhD in reconfigurable computing. So that's I'm in the process of publishing a paper on a reconfigurable computing architecture, which is what I used to do before I now do this. But this is way more fun. As I say, I get to talk to Google and meet the inventor of Unix. So yeah, I'll do this for a while.
That's an awesome show special, by the way.
Yes.
It does seem good.
I have a box of pies, so I know that that's a good deal.
Okay. Good deal.
Alright, so I just went to that website and it says that they're not going to have stock until the 17th.
So what's probably happened?
And the product description was very vague. I wasn't sure if I had to get the code right.
So much like this chap here has realised it's a good deal. That's probably happened at the 100 or so people who turned up to the 16 talks I've already given. Which is probably why. Actually,
That's still a great deal.
Yeah, while I was in Silicon Valley, I was saying, go and order from MCM, they have stock. And I said, one of these days I'm going to say it, they're going to have sold out of stock. And they actually had sold out of stock.
Yeah, I just checked the MCM says that they, if you just try to choose a board, they say, oh yeah, we'll have that stock in February 18th.
Yeah, so I've probably sold out all of the stock of MCM whilst I've been out here. Sorry guys. There are other distributors with stock. Adafruit have loads of stock as well. Actually, if there's anyone making bulk orders, Adafruit are doing a deal where if you spend $350, they'll give you a free Pi, which is pretty cool. So you can go and buy like a new HDMI TV, which you might want anyway, and then get a free Pi with it. I mean, that's kind of weird. Buy your peripherals and get a free computer, but you know. That's awesome.
So how do you get that deal?
Pass. You go to some kind of website. There's a QR code, right? So maybe scan that.
Okay.
Yeah, so use the QR code or just go to that site and then go up and type in that SKU code in the search box. And what it gives you will not say Pi anywhere on it.
Okay.
But it's $24.52 and they'll have stock.
Yes, my Twitter feed is the best way.
Okay.
If you tweet me, I'll tweet you back the link. Or if not, if you go through my Twitter feed, then all my links. So I'm just Rob underscore Bishop. I'm Rob underscore Bishop on Twitter.
Okay.
Please tweet about this though.
Yeah, that's cool.
My pie hanging off some pegboard.
Talking about distributions for Pi, there's an Android binary. It's not open source yet. We're working on it. There's Boot to Gecko, which is the Firefox OS. There's a Qt 5 development environment with hardware acceleration. There's Chrome OS. I'm trying to think what else there is. There's a Django distribution, which is set up to be a web server. There's Arch, there's Puppy, there's Gentoo, there's Slack, there's Debian. At this point, right, if it's not already been ported, there's probably a group doing it. I mean, because porting's not that hard. Now there's so many other platforms which have done it. All the binaries you need for the GPU stuff are there, and then it's just a case of running it through GCC with, V6 and whole lot of those.
You have the Wi-Fi.
I don't know how they're doing it.
Yes, there's no Wi-Fi on the
know how
board,
they're doing
but you can use a USB Wi-Fi. I'm pretty sure there are people in here who will have Pi's working with Wi-Fi who can recommend you that.
I get it.
I'm sure there will be.
And it might actually come with the image on it as well.
Yeah.
For me, that's the value.
I have a really pretty Pivo case to give away to someone who has something cool to show or talk about.
Store count. I had them yesterday too, but I didn't get a chance to show you. Yeah, take that guy.
Do you have a cool project?
Kind of, sort of.
Okay, that's awesome.
What's that other board that you have attached to it?
I was going to go and talk to that. So that's a GURT board. So it's an expansion board designed by an engineer at Broadcom called Gert Van Loo. It allows you to. He basically wanted to move really big stuff. The GURT board's rated up to 4 amps with an actual physical fuse, which is awesome. You don't see fuses on PCBs often enough. It's 5-volt logic, so it's equivalent with all your Arduino stuff, and it's got an Atmel chip on it, so you can run your Arduino programs on it anyway. And there's all the Python libraries and the full set of tutorials and stuff.
How much?
$40 as a solder together kit. Which I always like to say, when the peripheral hardware is more expensive than the computer, you know how hard we worked. So, so I'm in training, so I'm really not a teacher. I can do I can talk about what I know, and I can try and relate to it, but I'm really hesitant at putting myself out as an educator because I'm really not.
Have you been involved in the jam back in the UK?
Yeah, so I've spoken to the Peninsula Meet. There's a Peninsula Meetup group. It's probably I'm in Southern California now, right? So that's too far away for you guys. I think there's one. Yeah, I think there's only really close to here. I think there's one in Irvine. That's where Broadcom's based. There's lots of jams going over in San Francisco and the Bay Area. One operating out of the Computer History Museum. I've go to quite a few back in the UK.
He wins.
I'm doing some really big conferences in the next few months. It's kind of crazy. I'm doing one in Lisbon with 900 attendees. I'm giving the keynote, which is pretty cool. But yeah, again, I kind of miss kernel development. Exactly. And then the bugs in that, I just get all the issues from GitHub the next day.
So this is an Atrix adapter to run on it.
That's awesome. People see that.
The what?
Yeah.
It's cool.
Yeah.
This Atrix start with a CPU of its
60.
It's just a battery and a display. So it's quite nice. You just need 2 cables. You need to rewire it. If you follow my Twitter, there's a tutorial I tweeted about possibly yesterday. I don't know what day it is. Recently, someone put up a tutorial on how to build one of these. So if you want to make one, you can follow that.
That's cool because they're offloading those things for like dirt cheap right now.
It used to be. Legitimately, the price has gone up since the Raspberry Pi came out because people are rebuying.
Go ahead and launch the yeah, we got it for like $60.
Yeah.
So here's an example where it's loading in low res.
Right. So it might be that the display on that isn't reporting what it actually is. You can go into your config.txt on the boot partition and manually set it to what resolution you want.
Okay.
If you have a look in the forums, or there might be someone here who's done that.
Like the USB was 13, door was 9.
Yeah.
The
Probably.
keyboard was most expensive.
This works pretty well. And the Pi powers off of the battery in here.
Do you have how many what?
2.
Just 2. Yeah, cool. So you're doing the back powering. So did you remove the USB, the polyfuses?
I don't think this one had it.
The Rev 1 will. They are.
This is a 2.
No, that's a Rev 1. Because of the mounting holes, right? I think they're possibly underneath. So if you're back powering with the polyfuses, you get some voltage drops. It might be slightly unstable. doesn't. Yeah, no, I'm wrong. We stopped fitting the polyfuses on the Rev 1s, on the last few Rev 1s we made. So there's effectively 3 versions of PCB. There's the original PCB with the polyfuses, there's the Rev 1 where we didn't fit the polyfuses, and the Rev 2 where there are no polyfuses. I forgot we did that.
Yeah.
Sorry, yes, you're right, there's no polyfuses.
So there's nothing.
No. Sorry, it's like trying to support an entire computer is quite fun, especially with multiple runners.
Well, everyone didn't see that. I guess some people would do it. It's a nice platform.
Yeah, no, I've seen a couple. That was pretty cool. It's nice, it's a whole platform as well. And it's kind of nice that, like, this is a computer that you can see the stuff, so people often ask us, like, why didn't you produce a case? And the answer is because, you know, you give this to a kid and the first thing they say is, hey, what's that? People go, well, aren't you worried that, you know, the kids can break things? Aren't you worried they're not robust enough? You know, like, these components will come off. I'm like, yeah, you can solder them back on there. So this big electrolytic's quite near the power micro USB power jack, and we see people like using it as leverage to push it in. And you know, I quite often speak to kids who are like, oh, not this silver thing off. I'm like, it's an electrolytic capacitor. Like, what's that? I'm like, repeat it. And you know, and then we go and repair it by soldering it back up again. And the point is, okay, you know, it would be easier to use if we'd encased it, but they wouldn't have learnt what an electrolytic capacitor is. Yeah. I mean, not all electronics is like a black cycle grounded course, right? It looks like that.
How many layers?
6 layers. It's got partial lasered blind wires, I think, so it's pretty advanced. Like, it's a cell phone. Standard. Yeah, this is the interesting thing. So when we open source this, like, people have said, you know, you haven't open sourced the PCB design. Problem is, very few people could remanufacture this anyway, because the cost for a few of these boards would be expensive, because there's only a few places that can manufacture this stuff. And then you can get hold of the chips. So schematics are useful. PCB files really are, because you couldn't clone it right now.
But you don't release the burger file?
Cool. Sorry?
You don't release the burger file?
No, not yet. We're going to. We didn't release the Gerbers initially just because obviously we had to convince Allied and Farnell that it was worth taking on a tiny margin to produce things. And trying to say, hey, what we're going to do is let you manufacture something that we'll let anyone else manufacture who wants to as well. You know, that wasn't much of a deal. So, any of the stuff we've done which seems a bit, not evil, but against the open ideology, it's probably just because there are hard decisions we have to make to get them shipped. And shipped and in the hands of kids is more important than sitting around and worrying about ideology. Right? At least, I think so.
I thought anyone was talking about it.
I don't know. I think if you could, there'd be some companies. I don't think they'd be able to afford to do it. I mean, I don't see how
Making your price point, it's not profitable.
Yeah, exactly. The problem is I don't see how a privately funded company or a for-profit company could make this for $35. Because the point is, we make virtually a profit margin. You couldn't pay for the engineers you need to go and make this happen. You can only do it as enough profit. You know, and then you need access to the chip. So we did what we thought would be very difficult for anyone else to do. But as I say, you know, the challenge is out there for someone else to do it better and cheaper. I'd love to only have one job, right? So please someone go and do it.
It's a good thing you did it after job started.
Well, I mean, so I was at Apple, and I was talking to some of the more senior guys there, and actually, they think this fits in quite nicely with their philosophy, because if you think about it, what Apple's trying to do is they're trying to remove all of the abstraction of a computer. They're trying to make it so that it's as transparent as possible to get to digital content, and that's a good goal. You know, I mean, if what you're trying to do is make a platform for delivering content, that makes sense. You know, engineers are lazy. We don't want to know how it's being relayed. We just want the content, and I approve of that. The problem is that by abstracting all of that, if you don't need to know anything about how it's working, you don't learn about it, right? So you need something like this at the other end to make sure that we still have the engineers to go and produce those things in the future. So, you know, actually, you know, it kind of works quite nicely. I mean, one of my first events with this was in literally a garage in a house, over in Staten Island. And there's maybe 25 people turned up, and I like this sort of homage that I was selling a single board computer to hobbyists in the garage. That was kind of cool. It wasn't at Castle, right?
Yeah, it's good. Thank you.
Yeah, I'll go get it. I've learned by this point to make sure I eat them before I come out, because otherwise I just never get around to it.
Do you have any comments about if somebody was going to try to do a project where they wanted to use this as part of it, but so obviously you could say, well, you've got to go out and get a Raspberry Pi. About again, getting quantities greater than 5 or something like that to include it as part of the project.
Yeah, so we have absolutely no problem with people producing closed products around the Raspberry Pi platform. As long as they state there's a Raspberry Pi in there, we're happy with that. The reason why we don't mind about that is because if it's a commercial project, you've probably got talented engineers working on it. And that means we've got talented engineers working for free on fixing our various bugs. So that's one good thing. The second good thing is I haven't yet seen any engineers who get these and don't make cool stuff themselves. When I was at Noisebridge, some guys from Oracle said, hey, we're in town for Java 1. Could we come and give some demos at your talk? I was like, yeah, it'd be great to see some Java demos, right? Oracle guys turn up, like senior Oracle developers, and they get out some Lego, like, I want to show you this awesome Lego thing I made, which is controlled by my mind. And I'm like, wait, you're not showing anything to do with Java? And they're like, yeah, we've got some stuff going with Java, but I want to show my project, right? And so the point is that actually, if we want to get cool projects to inspire people, getting it in the hands of talented people who can go and do those things is a useful thing. The other point is, we're a charity, right? So any companies that are buying vast numbers of these, we don't make much they don't make much margin, but we do make some, right? So if we sell a lot of these, they're effectively giving us more money to spend on educating kids. So everyone wins, right? Plus, as an engineer, as anyone who's an engineer here will know, the most satisfying thing as an engineer is to do something that people use, right? And just getting these in the hands of more widely used projects, more people, that's very satisfying personally that we've done something that's useful enough to do that, right? There doesn't seem any point in restricting people making things with your toys.
This is probably a question that's already been answered. Many of us were too far back. Are any available today for sale?
Sadly not. But if you order them online, you can get them in 2 days' time, basically. There's a quick sell. The problem is if I was to sell them today, when you add in all the taxes and extra costs, it'd be a lot more than $35. It's basically this.
Okay. Did you bring both types here today?
I only have Rev 2s. So we only manufacture Rev 2s. Oh, okay. So it's quite funny, when the Foundation want boards, we have to go and buy them too. We buy them, we have different contacts, but we don't have a stock of boards in the office, we have to go and get them. So I could only get hold of Rev 2s because they're the only ones we manufacture. In the UK, you can definitely get Rev 2s. If you're really worried about getting a Rev 2, if you order it from the UK and ship it over, you'll get a Rev 2, but this kind of seems pointless.
That's the one with the local area network, right? That's the one with the land.
Yes, you can't buy one without a LAN right now.
Oh, okay.
This just has...
Yeah, well, I remember looking at before. It was AB.
Yeah, you're thinking AB. This is PCB revisions. So, literally, it's mounting holes, ARM JTAG, I2S,
Have you upped the
polyfuses.
Have you upped the frequency at all? Or is it still the same?
Yeah, these run at... this one's running at a gig.
Oh, okay.
Well, a gig maximum. It doesn't run at a gig constantly, it scales it to load.
And Rev 2 is the one without the polyfuse?
Yes, although apparently there's some Rev 1s that polyfuses as well, which I forgot. So,
okay.
Yeah, yes, you can. I don't think we release it as an official, but you can do it in the... If you're using the GUI, I don't think you can. But if you go on the forums, people have... you just have to write some stuff in your boot, in your command .text. Start on one that boots up. You can set it up. You can underclock it. And then it's less bad.
So do you have the camera stuff and the TFT's touch screen? Is that stuff available yet? Or?
The camera is going to be available when I get home and write the software. We have the prototypes in terms of hardware now. I can't show you it running because I haven't written the software. but it's a 5 megapixel camera sensor. It can do 1080p video encode, 5 megapixel JPEG hardware encode, give you a raw bit stream for OpenCV or something. It's going to be $25. The idea is we'll have the Model A and the camera for sale before Christmas. I kind of don't want to say that too much because I'm then setting myself up for my own time pressures, but that's the plan.
And then the touch screen too? Is that future development?
Yeah. There's no reason why you couldn't make your own, because it's just I2C controlled SPI and stuff like that.
Okay.
I kind of think at this point someone will probably come out and do those things before we do them. Which again, we don't mind. Like, I'd rather have like some time. I2C controlled, SPI, well CSI, but running on the SPI pins, pretty much the same thing for data. The other one has DSI by the way, which is for displays. It's like camera serial interconnect, display serial interconnect. Don't know why SPI stands for serial.
I'm sorry, I was out there and I couldn't see anything or hear anything, but is that a board that you're selling for?
That is a GERT board. It will be on sale as soon as the FCC let us sell it.
It looks like it's got a motor driver and a bunch of IOs.
Basically, yes. You've summarised it quite well.
Okay.
It comes as a kit. It's going to be $40. There'll be Python libraries and tutorials and stuff. You can have a look at it. I mean, you can identify everything that's on the chip.
Well, yeah, I noticed that with these. Okay, it's got a lot of IOs here.
They're all 5-volt I/O, 4 amp max, so you can run nice motors.
Oh, okay.
It's got an Atmel chip on it, so you can run your Arduino code on it.
Okay. Okay, this is the motor driver here. And,
actual fuse. How good is that?
This is a fuse?
Yeah. No, that's a fuse.
Oh, okay. Yeah, it does. Oh, that's good.
Let's see fuse on electronics now.
Is it do analog also?
Pass. I don't think. Yeah, the Arduino. There's no DACs. I don't know if there's any ADCs or DACs on this board. I think there probably are. There aren't on our board because analog silicon is expensive.
Well, you can always do a resistor network and fiddle with a couple of bits here and there.
Yeah. You still need the op amps, and those chips are more expensive. Op amps are expensive compared to digital ICs.
Looks like it's a big fun board.
Yeah, so it comes as a kit, so you sold it together yourself.
Okay. I'm sorry, I just. Well. So we got switches, we got LEDs that we can fiddle with.
All the schematics are available online. I mean, the foundation didn't make this, it's just one of the Broadcom engineers did. I bring it around because people ask the questions. But I had nothing to do with the design of this board.
Okay, I don't have my glasses, but are these op amps or comparators?
No, that's an Atmel chip. I'm not sure what these chips are. I haven't read this whole screen. But I mean, as I say, all the schematics are available online, so I haven't seen anything.
Photo isolators? I haven't had any problems. I literally have touched it.
What?
Yeah.
I've done that with other computers that almost come back.
Oh, okay. 244, so that's like a buffer. Yeah, so those are like Tri-C buffers or something.
Do you know if these chips can run Java bytecodes?
Maybe it also maybe you can do some shifting.
They didn't implement contact switching in so it's just better off using JPEG.
But it doesn't.
Oh, okay.
And they're like, oh, okay, so I can run XE or Y. No.
Well, we got enough potential.
That's realistic. It's not going to work.
Use the Arduino IDE program.
So the nice thing about the Pi is you don't really need an IDE, right? You can do it using Vi in the terminal on the board. You know, quite often people get the Pi and they're like, yeah, I wanted to write some Python, but where's Eclipse?
That's a lot of nice IOs. And I like the fact that it's all
you can barely even write his name.
and a little bit of area for putting your own IC.
Oh, I'm staying with my daughter. She's almost 5.
Well, 7-year-olds can use Scratch quite comfortably.
I like this.
So I'm sure with some effort you can get them to do younger. And hey, who doesn't like blinking LEDs?
Oh yeah, she sits down with her laptop. She sits down with Tux Paint, sits there and paints things, and she's great with the mouse. I remember when she first started using it, it was like, you know, all over the place with the mouse, and within a couple weeks she was really good clicking around.
You see, I think this and iPads actually go together quite well, or whatever tablets are called, right? Because I think if you're teaching something where the aim of the game is the content you're teaching, like maths or reading something, having a completely transparent computing device makes sense.
Yeah.
You know, but if you want to teach computing, it doesn't make any sense. You know, so I think they work.
I've got a 1.5-year-old, and she will pick up my iPad. She knows to swipe at the bottom there, and she starts swiping back and forth, you know, to go back and then just start.
They did a good job in designing that UI.
Yeah. Here's one of your nemesis to compare to.
So which one's this?
That's the
Pogo plug.
Guru plug, yeah.
Guru plug.
Yeah.
Yeah. So I believe this is entirely closed.
It's got a couple problems. One, it overheats. Two, you have to buy like a $60 JTAG debugger just to get Linux loaded on it. And those are the main ones. And like all of these other little embedded boards like this, it seems like there's a pretty lengthy process of getting the tool chain down and just getting a dumb raw Linux image on it before you can do anything.
Yeah.
And I think the idea of something that you put a stake in the ground and there's going to be a bunch of people supporting it, it doesn't have to be the absolute best, it just has to be universal.
Well, as I say,
it'll
in some
become
ways
the best.
I'd be quite happy to go back to being a kernel developer, right?
Yeah.
But, you know.
Well, it'll become the best just by default. It's a software, yeah.
The reason why it's going to be really hard for someone to beat us now is because A, you're not going to be able to get any profit at the price point, so I don't know how you get any kind of funding. I mean, we're self-funded, right? The founders put in their own money, Eben mortgaged his own house, you know, we own all of our own equity.
These
it's
are
a testament to me talking to you guys, right? Although this sounds like a sales pitch, I have no equity and I've not yet ever been paid to work on this. You know, I do this because it's cool. And even when I'm paid, you know, I'm going to be paid probably less than I would do if I was getting into other jobs. And doing this is a good fun thing to do. Well, yeah, that's I mean, this is my vacation, right? This is my sort of vacation because I was like, well, everyone was like, well, we need to go and promote it in the US because so we sold 500,000. We sold the same number into the US as we did into the UK, right? Per capita, that's pretty terrible. So I was like, yeah, I'll go do that because you know I have so much grad school debt I couldn't really afford a holiday to Brighton. So I was like, yeah, I'll go do this.
Would there be, if you were to be able to get somebody to put together a kit and add a little more profit to get it into schools, could that help you guys with funding?
So for example, Adafruit sell these for $40 because they have to cover their own shipping.
Yeah.
That's kind of fun. We have no problem with close. We have no problem with profit. You know, it's just we've done this to make it as cheap as possible. The point is that we've cut out all of our profits.
The company I work for has two. Well, I was actually the tag out.
Okay, I will come chat to you.
So, this is a hackerspace RFID badge-in access security system.
Yeah.
One of the other spaces we made one of these for ported the monitoring system to Raspberry Pi. So it SMSs everyone and gives you the open-close status of the website and stuff.
Well, nice. I mean, because you have high-level languages, right? You can use Twilio and Ruby. You can do something. You can write something to do that in like an hour. Writing web apps on the Raspberry Pi is really.
There's just no good reason to have an internet-facing device running like an Arduino. This actually has a little embedded Arduino. And guess what? USB cable over the Pi, and now you've got a full TCP stack and all the Linux facilities, shell scripts, Python, whatever you need, right?
Python's my preferred, like, because I have a background in game.
There's a project called the Sea Perch, which is a cable remote underwater vehicle.
I'll send you videos.
For like grade school and junior high.
Right.
And then for college, there's RoboSub and RoboBoat.
Yeah.
There's nothing for high school.
Okay.
So the Navy approached David. Whatever. I forget what it is.
Actually,
DNR.
TH, I think.
Anyways, somehow the Navy got approached them and actually gave some money for a year.
Right.
To make an in-between product. That one, it isn't autonomous, but remote control and has intelligence on it.
Right.
So TH did a lot of work, but it was sort of fragmented. He went back to Germany, and they asked LA Robotics if they wanted to help, and so I've been doing that. So I attempted writing a curriculum.
Okay, well we'd absolutely love to see what you've been doing.
It's with Arduino.
Right.
And the thing is that the next stage is we remote control to a laptop, and I'd much rather put one of these on board.
Yeah. Well, you can port
less money than
port the code very easily. I mean, all the stuff you've got, you can port without mixing it.
Well, we probably keep the Arduino motor control, all that stuff, because we've already done that.
Yeah.
The way we're teaching is we have a car, and they do that in the classroom, then they can put all the electronics in a waterproof box onto the boat. And then what this will do is this will talk to the Arduino. So this will, if it has vision or mapping or anything else, this will do all that. So the Arduino just collects the sensor information and sends it off directly.
Makes sense. And that's good design principles, right? Because you always use the cheapest thing.
My
first started doing this, this was 18, 20 week lead time, and now that they're available, I figured by the time the class is ready for that, it'll be spring. You guys hopefully will be in normal production.
Again,
and they don't need the video either.
Please stay in touch over Twitter. Please blog about what you've been doing, because we need you guys to inspire. So I mean, there will be people here who have gone, I'd love to teach a class, but I have no idea what to do. Right. And we just need you guys to tweet to say, hey, you can do it, and that's useful. Case studies and materials is useful. If you need any support from us, we'll do what we can. The cam will hopefully be out before Christmas.
You said $25? $25. And what, how many megapixels?
5 megapixels.
Probably more than what they really want, but you can always...
I mean, you could always use a USB webcam, but this is probably, for the quality, I should think of it.
Oh, one of the things the Navy guy said is, can you find a red buoy?
Where you can,
so we're looking at color sensors and stuff, and it's not going to happen. So we need a camera. So
if you're just detecting like one buoy, then you need to. Then you can always do it with like IR sensors and stuff. Quite often we talk to people. So webcams with cheap. So people often trying to use Kinects and stuff. My advice for using a Kinect: go get a cheap IR filter for. Like a DSLR or something, right? Get a couple of high-powered IR lights, use a webcam, right? The same with this. If you want to detect a particular color spectrum, get the right filter, just look for intensity. And then, because a lot of people are trying to run things like OpenCV to do stuff you can do with a bit of glass, and that's not optimal design, right?
They want to be able to define an object and be able to find it. The obvious thing is they want to teach the kids how to do this stuff, so when they graduate, they then join the Navy, and they usually contact. Actually, just came back from a conference, and the Custos are really not Jacques, I forget what his son's name is, but they're on board with it. Cool. They're really excited.
Well, it's going to be. I mean, if you want to go into any kind of defence, you're probably going to have to work quite hard to not be involved in a scheme using these. So defence contractors love them because they're all UK manufactured by UK engineers, the US companies and things. So a lot of the Lockheed and Northrop Grumman outreach and supplies. I had dinner with their cyber warfare executives in DC. This again was one of those things I just think, well, how did this happen again? But it's kind of cool. Yeah, it'd be great for them.
Yeah, at my high school, which is not too far away, we have a robotics team for FRC. I know robotics, and last year it was a basketball game. Actually, they had reflective tape for the squares, and you actually had a camera to detect it. So you'd actually have to shoot the LEDs off of it and get the square back to figure out where the basketball hoop was.
That's awesome.
To shoot it.
Yeah. No, if you want to do, I mean, OpenCV in general, you don't need. You can probably do OpenCV with physical hacking. If you want to detect things, filters and LEDs tend to be able to do a lot more efficiently. Particularly depth. People instinctively think they need a Kinect. No, you just need a tiny bit of IR glass and a couple of LEDs. Right?
That was the game console. Oh, the Atari 2600, yes. That was the game console. The 800 was a PC. It was one of those computers in a keyboard.
So do you have part 2 or are you done?
I think we're done.
Okay.
I covered most of the stuff, right?
Yeah.
So.
Didn't they have a couple of them? Yeah, they had the 800, and then they just had
I actually haven't. No, I've got to talk tomorrow. I've got a day off the day after tomorrow.
Yeah.
So what are you doing the day off?
I've managed to brilliantly organise my day off being when I'm giving a talk down in Crash Space on Venice Boulevard. So I'll be in the right place to have a day off, right?